I was asked to give a little refresher on how to calculate the Gini coefficient given data for the Lorenz curve. So let's remember first what the Lorenz curve is. We take all the population and divide them up from poorest to richest and place them on the horizontal axis. Then on the vertical axis, we list the cumulative amount of income that each of those percentiles has. So here I've just made up some data. So the population is broken into deciles, or 10% each. And then we have the percent of cumulative income that each decile gets. So obviously we start at 0, 0. And then in this example, like one of the examples in the book, the bottom 10% of the population doesn't have any income. We can assume that they are unemployed and that what we're measuring here is market income instead of disposable income. And then going from the 10th to the 20th percentile, they get 5%. And then the 20th to the 30th get another 5%, so that's 10%. And then the 30th to the 40th percentile get another 5%, so that's 15%. So each of those deciles get 5% of the income. Then we move up from the 40th to 50th, they get an additional 10% of the income, so that is 25 total. And then 60th, 35, so that's another 10. 70th, 45, that's another 10. 80th, 55, that's another 10. So each of those deciles of income, of population, gets a decile of income as well. And then going from the 80th percentile to the 90th percentile, they get 20% of income. So we go from 55 to 75. And then the last decile, the top 10%, gets 25% of income. And so we move from 75 to 100. And of course, we have to end at 100 because 100% of the population has to have 100% of the income. So we can use that to graph our Lorenz curve, right? So the Lorenz curve is the blue line. And remember that the orange line is just the 45-degree line. So our Gini coefficient, remember, is just A divided by A plus B, or the area under the orange line. But that's not an obvious way to, there's no obvious way to calculate it, so we're going to walk through and see how to do that. So the first thing we need to do is we need to figure out how we're going to calculate A and B. And actually, we're not going to calculate A right away because A is going to be harder to calculate. What we're going to do is calculate B first, and we're going to just break it up into triangles and rectangles. So if we do that, we can see, all right, we can break it up into a whole bunch of different triangles and rectangles based on the fact that the first 40, from the 10th percentile to the 40th percentile is a straight line. They each get 5% of the income. And then from the 40th to the 80th percentile is a straight line. They each get 10% of the income. And then the 80th to the 90th, and then the 90th to 100 percentile. So we can break that up into triangles. So 1, 3, 5, and 7 are triangles, and then rectangles. 2, 4, and 6 are rectangles, and we can calculate the area. So remember that the area for a triangle is just 1/2 times the base times the height. So for 1, the base is 40 minus 10, or 30, and the height is 15 because they get a total of 15% of the income. So the area is just 1/2 times the base, which is 30, times the height, which is 15, and so that gives us 225. Now for 2, that's pretty easy. That's just a rectangle. So the base is 80 minus 40, or 40. The height is this 15% of income. And so 40 times 15 is the area of 2, and that's 600. For 3, we have another triangle. So our base is, again, 80 times 40. The height is 55. That's the percentile of income that goes to the top, to the bottom 80% of income, minus 15, which is the income that goes to the bottom 40% of income. So that's 40. 40 times 40 times 1/2 is just 1600 times 1/2, or 800. Then 4, the base is 10, just 90 minus 80. The height is 55, and so 55 times 10 is 550. For 5, that's another triangle. The base is 10, the height is 20 because it's 75 minus 55, and then 1/2 times 10 times 20 is just 100. And then 6 is another rectangle. It's just 100 minus 90 is 10 for the base. The height is 75. The area is 750. And then for 7, we have one last triangle. 100 minus 90 equals 10. The height is 100 minus 75, or 25. And the area then is just 1/2 times 10 times 25, or 125. All right, so we've broken up the area that we called B into 7 different triangles and rectangles. So we can find out the area under the Lorenz curve. That's just 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. We add all that up, we get 3,150. Now we can also calculate the area of A plus B, which is the area under the 45-degree line. That's just a triangle, and the base and the height are both 100. So it's just 1/2 times 100 times 100, which is just 1/2 times 10,000, or 5,000. So now we have B, and we have A plus B, so we can find A. And so A is just going to be A plus B minus B, or 5,000 minus 3,150, which is equal to 1,850. And then the Gini coefficient is just A divided by A plus B. So the Gini in this case is 1,850 divided by 5,000, or 0.37. So remember, the Gini coefficient is always between 0 and 1. 0 is perfect equality because then A is 0. Everybody has the same amount of income. And so A divided by 5,000 is just 0 divided by 5,000. It's just 0. And it goes up to a high of 1, which is when that last person has all the income. And so then it's just 5,000 divided by 5,000, or 1. Another way to answer the question in the problem set is by process of elimination. So you should always keep that in mind when you're solving a multiple choice question.